Hello everyone and welcome to our channel, where we explore the wonders of our universe. Today, we're taking a closer look at Neptune, the farthest planet in our solar system, and the discoveries made through the first real images captured by Voyager 2. Join us as we dive deep into the characteristics of this gas giant, from its atmosphere to its moons, and uncover the secrets hidden within this distant planet. So sit back, relax, and get ready to embark on a journey to the outer edges of our solar system. Neptune is a fascinating planet located over 4.5 billion kilometers away from the Sun. It is the farthest known planet in our solar system and is known for its blue coloration due to the presence of methane in its atmosphere. However, before we continue, take a moment to like this video and subscribe to my channel. Without much ado, let's dive in. The discovery of Neptune. Neptune was discovered in 1846 by the French mathematician Urbain Le Verrier. Le Verrier had been studying the orbit of Uranus, and he noticed that the planet's orbit was not following the path predicted by Isaac Newton's laws of motion. Le Verrier suggested that the gravitational influence of an unknown planet beyond Uranus might be causing the orbital anomalies. Le Verrier calculated the position of this hypothetical planet, which he called Planet X, and he sent his predictions to several astronomers. On September 23, 1846, German astronomer Johann Galle observed a planet in the position predicted by Le Verrier's calculations. This planet was later confirmed to be Neptune. The discovery of Neptune was a major scientific achievement as it demonstrated the power of mathematical predictions in astronomy. It also expanded our understanding of the outer solar system and paved the way for future discoveries. Voyager 2 and its mission to Neptune. NASA's Voyager 2 spacecraft was launched on August 20, 1977, with a mission to explore the outer solar system. It successfully passed Jupiter in 1979, Saturn in 1981, Uranus in 1986, and finally reached Neptune in 1989. The primary objective of the mission was to study the planets and their moons, as well as the interplanetary medium and the structure of the solar system. Voyager 2's mission to Neptune was particularly challenging due to the limited knowledge of the region and the need to target instruments while traveling at high speeds. Voyager 2 provided the first detailed images of Neptune and its atmosphere, including its blue color and powerful winds. The spacecraft also discovered Neptune's rings and several of its moons, including Triton, Nereid, and Proteus. Voyager 2 made its closest approach to Neptune on August 25, 1989, flying within 4,950 kilometers, 3,080 miles, of the planet's cloud tops. The images and data collected by Voyager 2 have been critical in advancing our understanding of the outer solar system and the formation of planets and their moons. The spacecraft continues to transmit data back to Earth and is currently over 18 billion kilometers, 11 billion miles, away from the Sun. Voyager 2's mission has paved the way for further research and exploration, with several proposed missions to study Neptune and its moons in greater detail, including the Neptune orbiter and the Trident mission to Triton. The appearance of Neptune and its atmosphere. Neptune is the eighth planet from the Sun, and its distinctive blue color is due to the presence of methane in its atmosphere. The planet is a gas giant composed primarily of hydrogen, helium, and methane. Neptune's atmosphere is known for its strong winds, which are the fastest in the solar system and can reach speeds of up to 1,200 kilometers per hour. One of the most notable features of Neptune's atmosphere is the Great Dark Spot, a large storm system similar in appearance to Jupiter's Great Red Spot. This dark spot was first observed by Voyager 2 during its mission to Neptune, but has not been seen in recent images, leading some scientists to believe it may have dissipated or been replaced by other storms. The planet's atmosphere also contains a complex system of cloud bands and weather patterns. Neptune's southern hemisphere is dominated by a large, bright cloud known as the South Polar Hood, which is believed to be composed of methane ice crystals. The planet's strong magnetic field, tilted at an angle of 47 degrees relative to its rotational axis, is generated by convection in its outer core. Despite being the farthest planet from the Sun, Neptune is still the subject of ongoing scientific study and exploration. Proposed future missions to Neptune and its moons include the Neptune orbiter and the Trident mission to Triton. which aim to provide further insight into the planet's atmosphere, magnetic field, and moons. Neptune's Great Dark Spot and other atmospheric features. Neptune's Great Dark Spot is a notable atmospheric feature that was discovered by Voyager 2 in 1989. It is a large, oval-shaped storm, similar to Jupiter's Great Red Spot, that rotates counterclockwise and can reach wind speeds of up to 2,400 kilometers per hour. The Great Dark Spot is believed to be a high-pressure system, but it has not been observed since its discovery in 1989, leading some scientists to speculate that it may have dissipated or been replaced by other storms due to Neptune's strong winds and changing seasons. Neptune's atmosphere also contains other fascinating features, such as high-altitude cirrus clouds composed of methane ice crystals and a complex system of cloud bands and storms. These features are driven by the planet's internal heat source and rotation. Studying Neptune's atmospheric features provides valuable insights into gas giants' dynamics and the processes driving atmospheric circulation and weather patterns. The data collected by Voyager 2 and other spacecraft have helped scientists understand better the complex and dynamic nature of Neptune's atmosphere and the outer solar system as a whole. Neptune's rings and their formation. Neptune has a system of rings that was first discovered in 1984 by a ground-based telescope. The rings are relatively faint compared to the rings of Saturn and are composed primarily of small particles of ice and rock. Neptune's rings are believed to have formed from the breakup of one or more small moons that were located in the planet's vicinity. The gravitational forces exerted by Neptune and its large moon, Triton, may have disrupted these moons and caused them to collide and break apart. The resulting debris formed the rings that we observe today. The main rings of Neptune are named after astronomers who made important contributions to the study of the planet, including Gallo, Leverrier, Lassell, and Arago. The rings are composed primarily of small particles, ranging in size from dust to boulders, with the largest particles measuring up to several meters in diameter. The rings are also characterized by several ring arcs, which are narrow, incomplete rings that appear to be confined by the gravitational influence of nearby moons. The ring arcs are believed to be the result of gravitational perturbations from the moons that cause the ring particles to clump together and form dense structures. One of the most interesting features of Neptune's ring system is its peculiar structure. Unlike the flat, disc-shaped ring systems of Saturn and Uranus, Neptune's rings are clumpy and irregular in shape. This may be due to the gravitational influence of nearby moons, which can cause the ring particles to clump together and form dense structures. The rings of Neptune are a testament to the dynamic and ever-changing nature of the outer solar system, and the data collected by spacecraft, such as Voyager 2, have helped us to better understand the processes that drive ring formation and dynamics in our solar system and beyond. The discovery of Neptune's moons, including Triton. Neptune has a total of 14 known moons, which were discovered over several decades using both ground-based telescopes and spacecraft observations. One of the most interesting of these moons is Triton, which is the largest of Neptune's moons and one of the most unusual in the solar system. Triton was discovered by British astronomer William Lassell just 17 days after Neptune was discovered. Like many of the other moons in the outer solar system, Triton is believed to be a captured object that was originally part of the Kuiper Belt, a region of the solar system beyond Neptune that is home to many small icy bodies. Triton is notable for several reasons. It is the only large moon in the solar system that has a retrograde orbit, meaning that it orbits Neptune in the opposite direction to the planet's rotation. It is also the coldest object in the solar system, with surface temperatures that can drop as low as -235 degrees Celsius, -391 degrees Fahrenheit. Triton is thought to have a complex geological history, with evidence of active cryovolcanism or the eruption of frozen materials such as water, ammonia, and methane. The moon is also characterized by a diverse landscape, including smooth plains, rugged mountains, and impact craters. In addition to Triton, Neptune has several other interesting moons, including Nereid, which is one of the most elongated objects in the solar system, and Procyon, which is one of the largest irregularly shaped objects in the solar system. Scientific discoveries and future missions. As of July 2021, there are no approved future missions to visit the Neptunian system, though NASA, ESA, and independent academic groups have proposed and worked on future scientific missions to visit Neptune. Specific mission proposals include a pair of probes by CNSA, a mission concept based on a twin spacecraft mission, a proposed collaborative flyby mission by ESA and NASA, an NIAC study of a mission to Neptune, a finalist in the Discovery program, and the current mission concept for a Neptune orbiter and atmospheric probe being studied as a possible large strategic science mission by NASA. Several other project options for both flyby and orbiter missions have also been researched, but none have been approved due to budgetary constraints, technological considerations, scientific priorities, and other factors. The lowest energy trajectory for a launch from Earth to Neptune uses a Jupiter gravity assist, and an optimal launch window was open for such a Neptune mission from 2014 to 2019, with the next opportunity occurring in 2031. These constraints are based on the requirement of a gravity assist from Jupiter. However, with the new Space Launch System technology in development at Boeing, deep space missions with heavier payloads could potentially be propelled at much greater speeds, and missions to the outer planets could be launched independently of gravity assistance. In conclusion, the discovery of Neptune and the first real images captured by Voyager 2 have given us a better understanding of this distant planet. We now know that Neptune's atmosphere is composed primarily of hydrogen, helium, and methane, and that it is home to dynamic weather patterns and a few distinct features such as the Great Dark Spot and the backward orbit of Triton. We also know that Neptune has a complex ring system, although it is much fainter than the rings of Saturn. As we continue to explore our solar system, we can expect to learn even more about Neptune and the other planets that call it home. That's all for today's exploration of Neptune and the first real images captured by Voyager 2. We hope you enjoyed learning about this distant planet and the incredible discoveries made through space exploration. Don't forget to subscribe to our channel for more exciting content about our universe, and leave a comment below with your thoughts and questions about Neptune. Thank you for watching, and we'll see you in the next video.